Okay, so this is the first problem from your released MSL, and in it, it asks you to find which expression is equivalent to x plus 3 cubed minus 9x times x plus 3. Now, one mistake a lot of people will make is they'll say, oh, x cubed is x cubed, and 3 cubed is 27, so this is x cubed plus 27, but that is not correct. X plus 3 cubed means x plus 3 times x plus 3 times x plus 3. And if you're doing it that way, you're going to have to distribute x plus 3 into x plus 3 when you multiply those, get an answer, simplify it, take that answer, all three terms of that answer, distribute it into the other x plus 3. And you can do that, that's fine, but it's going to take you quite a while. What I'm going to use instead is something called Pascal's triangle. And in Pascal's triangle, hopefully you remember it, you have a pyramid of ones on the outside, and then on the inside you have, in between the ones, you have a number that adds up to the two numbers above it. So we have 1 and 1, 1 plus 1 is 2, and then we have a 1 on the outsides. Next row, we have a 1 on the outside, then 1 and 2 is 3, 2 and 1 is 3, and then we have a 1. I'll do another row just so you can see it. We have a 1 here, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, then I have my last one. Now, what we're looking at is, first we want to do this, and then we'll do this and put them together. So this x plus 3 cubed is what we're looking at now. So to the third power, so we're looking at row 3, that's this row. You could say it's named for the second number in the row. So we're looking at row 3. I'm going to get rid of everything else. Okay. And I'm going to spread this out. So hopefully you remember what goes in between these, but if not, that's fine. So first you have x for your first term. So what I'm going to do is I'm going to go through and put my x's on each of these. Well, you don't really need it on the last one. You do x, you put 3, start on the first one, put your 3 x's. On the last one, our second term you see is a positive 3. So I'm going to put 3 here, and a 3 here, and a 3 here. So what I did is I had my row, which was 1, 3, 3, 1. And I have a cube, so I put in x, 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 and then I had a 3. So starting on the opposite side, on the right, I put 3, 3, 3. And now I'm going to do my powers. So you start with the highest power. Actually, let me go ahead and put in my addition signs here. Okay. So we've got now we have an x cubed, and the next one is going to be a squared, and the last one's going to be a 1, and technically the very last one has a 0, but since it's a 0 you don't have to put it. And then from this side we have 3 cubed, and then down here we have 3 squared, and this would be 3 to the first, and then 3 to the 0. And now I can just simplify this rather than doing all that distribution. And it might seem like more work, and maybe with 3 it's about the same, but once you get more than 3, this way is definitely easier. So we have 1 x cubed, I'll come back and put the cubed in a second. Then we have plus 3 times 3 is 9, x squared, so plus 9x squared, and again I'll come back and put that in a second. 3 times 3 is 9, times 3 is 27, so plus 27x. And 3 cubed is 27 times 1 is 27, so plus 27. Now, as I promised, I'm going to come back here and put in the powers. So we have cubed and squared. Okay? And that is what we get from this section. Now we have minus 9x times x plus 3. So I'm going to continue this. Negative 9x times x is minus 9x squared. And then we have negative 9x times 3 is minus 27x. Okay? So now we have this whole thing, and all we have to do is collect like terms and we're done. So x cubed, this is our only x cubed. So all of these have just x cubed, so it could be any of those. So we have 9x squared minus 9x squared. Those are going to cancel out. So I can cancel those out. Then I have 27x minus 27x. Those will also cancel out. So I'm just left with x cubed plus 27. And that's letter A. And that's it for number 1. Okay? So when we simplified all this, we got x to the third plus 27.